All right, so here's number 8. A helicopter pilot drops a package when the helicopter is 200 feet above the ground. Rising at 20 feet per second. How long will it take the package to hit the ground? So that's part A, how long? And then part B, what is the speed of the package at impact? So to do this, we have to actually build our formula for S of t, and I didn't show you how to do that earlier. So here's how to do that. And this is something that if you've had physics, then you might know how to do this already. So our S of t equation, the position function, has this general formula. So the way you can build this formula is you find the initial acceleration, multiply that with t squared, and then you add the initial velocity, multiply that with t, and then you add the initial height. So A0 stands for initial acceleration. And the initial acceleration number could change depending on if you're working in feet or if you're working in meters. So if you're working in feet, you would use -16 for your initial acceleration. And if you're working in meters, you would use -9.8. And so think for a second, why is this negative? Why would the initial acceleration be negative? And the reason for that is because of gravity, basically. So gravity pulls everything downwards. So any object on Earth would have this acceleration of -16. So that's always pulling on things. So gravity, the acceleration due to gravity, it would be -16, or if you're working in meters, it'd be -9.8. So then V0 gets multiplied with t, that's your initial velocity. And then Y0 is your initial height. So in this problem, we're not given the equation, so we have to start by working that out. So if I read through this one more time, it says, the helicopter pilot drops a package when the helicopter is 200 feet above the ground. That's your initial height. So Y0 is equal to 200 feet. It says that the helicopter is rising at 20 feet per second. So it's rising at 20 feet per second. If you look at the units there, feet per second, that's a velocity or a speed. And since it's rising, in other words, it's going up, that means you would have a positive velocity. So our velocity is a positive 20 feet per second. And then we also have to know the acceleration. That's not told to us, but since we're in feet, we know that our acceleration will be -16. And the units for that would be feet per second squared. So now we can use that to fill in the formula for S. So S of t is going to be A0 t squared, so that's -16 t squared plus V0 t. So initial velocity was 20, so we add 20, multiply that with t, and then you just have to add the initial height of 200. All right, so there is our equation. So now that we have that figured out, we can answer part A. Part A says, how long will it take the package to hit the ground? So if the package hits the ground, that means it would then have a height of 0. So what we want to know is, since our position function S of t tells us the height at time t, if we just set this equal to 0, it'll tell us at what time it has hit the ground. So I can take my equation and set that equal to 0. So -16 t squared plus 20t plus 200 would be equal to 0. Now, looking at this, I don't know if we're going to be able to factor this. This is something that you just want to throw in the calculator. I'm going to do this in Desmos just so we can see how to work through it. So where is Desmos? Here it is. So the equation here is, I'm going to type this in. So the equation is 16t squared. So I'm going to use x's instead of t's just to make it easier to type. Plus 20t, so 20x plus 200. And I forgot a negative in front of the 16. There we go. Negative 16x squared plus 20x plus 200. So if you're doing this on the graphing calculator, unfortunately I can't show you how to do it on the graphing calculator from here. But how you would do it here is, well, if you want to know the max height, that's the top of this graph. That occurs at t equals 0.625. But if we want to know, excuse me, so the max height is, yeah, it's there. But then when does it hit the ground would be when it hits the x-axis down here. So if you just tap on that where the red curve goes through the x-axis, that tells you that intercept. On the calculator, you'd have to do a little bit more work. You have to hit a few buttons to find that. But we've done that before already in this class. So it hits the ground at t equals 4.215. And then the other question we have to answer is, what is the speed of the package at impact? So we don't need the graph anymore. So part B, what is the speed at impact? So notice they are asking for the speed here. They're not asking for the velocity. So that'll come into play in a minute. So if we want to know the speed, well, we have to figure out the velocity first. So we need to find the derivative of the position function. So v of t is equal to s prime of t. So we're taking the derivative. So this would be negative 32t plus 20. And then now we just want to figure out what's the velocity at this time that we found earlier, 4.215. So that would be, whoops. That would be negative 32 times 4.215 plus 20. And then I'm going to throw this in the calculator. Negative 32 times 4.215 plus 20 is negative 114.88. And this number is for velocity, so the velocity units would be feet per second. And that is it for that problem.